This lesson is determine the set of vector or orthonormal. If a set is only orthogonal, normalize the vector to produce an orthonormal set. So here I have vector 1 and vector 2. You're going to multiply them together. So 0 times 0 here, plus 1 times -1, plus 0 times 0, which is here. Now simplify, add, multiply, add, subtract. So it comes out to be 0, -1 plus 0, and it comes out to be -1. Since it is not 0, then it is not orthogonal. And since it is not orthogonal, then it will also become not orthonormal. One more time. Since it is not orthogonal, it is also not orthonormal. So we can stop here. We don't have to do much, okay? So one more time. Since it is not 0 when you do the dot product and it comes out to be not orthogonal, then it is also not orthonormal. Okay? Next. Here I have another vector, okay, u and v. I'm going to dot product them, so 0.6, -0.6 times -0.6 times 0.8 plus 0.8 times 0.6, and it comes out to be -0.48 plus 0.48. That comes out to be 0. Since the dot product is an orthogonal set, now we're going to do the second part just to make sure that it is an orthonormal set. Okay, so multiply itself twice. So multiply u itself twice, which I have here, 0.6, 0.6, -0.6, 0.6, and 0.8, 0.8. That comes out to be +36. 0.36 plus 0.64, add them together gives me 1. Now to repeat that process for vector v again, multiply itself twice, so 0.8, 0.8, 0.6, 0.6, comes out to be 0.64 plus 0.36, add them together gives me 1. And if you look carefully, this is a 1, this is a 1. Since they are the same, then it is an orthonormal set. Okay, so just for a recap, if it comes out 0, if the answer is not 0, then it is not orthogonal, and therefore it is also not orthonormal set. One more time. If the solution is not 0, then it is not orthogonal, then there is no orthonormal. So we can stop. We don't have to do any more. Okay. Next, if it does come out to be 0, if the solution is 0, then it is orthogonal. After that, multiply itself twice for first vector. Do the same thing for the second vector. If they come out to be the same, then it is an orthonormal set. If these two are not orthonormal, if these two values are not the same, then it is not an orthonormal. Then you have to do the normalize. Okay, so be very careful of that. One more time. If the solution is not 0, then it is not orthogonal set. So there is no orthonormal set. So there's no more. You don't need to go any further. We can stop there. However, if the solution is a 0, then there is an orthogonal set. And then after that, when you multiply itself twice for each vector, if they come out the same, then it is an orthonormal set. If these two are not the same, then you have to normalize so that it can produce an orthonormal set. Okay.